Welcome back. So in this video, we're gonna try to replicate the results of the paper by Martins et al. In 2015. So you should have a script called analysis_replication.r, which provides the code to get the results for this paper. The other thing, you should also have two datasets with you. One that says NSDUH_ready for analysis.r data, and another one that is the raw data set. We provided these two datasets because the raw dataset doesn't have all the recoding that they did in this paper. However, the NSDUH_ready for analysis, that has all the variables already recoded and is clean. We're not going to go through that part. We have provided also an R script for the data preparation if you want to do it by yourself. We're going to focus in this video on replicating only the analysis. So the first thing that we're going to do is we're going to go ahead and we're going to load our package, the survey package. So we're going to run this line here. Great. Now, this line of command is to set the working directory. You may be familiar with this if you use other statistical softwares. Basically, we are copying the file path here between the quotation marks where our data set is in our computer. So you can change this to whatever you save your data set. So I'm gonna go ahead and run this line of command, and then I'm gonna run this other command load to load my data set. So remember, this data set NSDUH ready for analysis.r data is the one that is ready to begin our analysis. Alright, so you can see in the environment the data set is loaded. It has 448,597 observations and 26 variables. So the first thing we need to do before we do any analysis is to specify our survey design object. So remember, this object contains all the data and metadata needed for the analysis, and it will also be supplied as an argument to the survey functions that we're going to do for analysis. And the main arguments that we need to specify the survey design for complex survey data are the ID. So this is not your usual ID. This actually points out to the variable that indicate the first stage of cluster sampling or primary sampling units, and the strata and the weights. Okay, so these arguments should be written with this little sign here, which are used in formulas to write formulas in R. So whenever we are writing this, is because we are referring to columns in a data frame or data set. In R, data frames are data sets. All right, so we're gonna run this line of command here, which is gonna create our survey design object. So remember, we are gonna use the function SBY_design that is provided in a survey package. So you can see RStudio gives you this little box to remember, to remind you, that what are the arguments that you need. So for this complex survey, we need to specify again the first stage cluster sampling. The variable is vrep, our strata, VESTR, our weights, WT_new, our data, which is called NSDUH. You have it here. And remember that in complex surveys, we first divide our target population by strata, and then we sample clusters within those stratas, so our clusters are nested in the stratas. So we set nested or nest equals true, and we're gonna run this. All right. So now I want you to turn to this table. This table shows the table 1 from the paper by Martins et al. So this table is the average annual rate of past year heroin use and adjusted odds ratio for past year heroin use among people 12 years and older by frequency of past year non-medical use of prescription opioids, racial ethnic group, and period. So there are a lot of results in this table, right? Okay, well, this R script has all the code that you need to reproduce every number in this table. So we're gonna focus first on these quantities that we are highlighting by a red square. So these are the past year prevalence of heroin use in the total sample for the periods of 2002 to 2005 and the period of 2008 to 2011. Okay, so now let's turn to our code, and we see that we're gonna use this command sby by. So because we want the prevalence of past year heroin use, the variable is her underscore R. Again, we call that variable with this little formula sign, and then the second argument is we call the grouping variable by which we're gonna compute these prevalences. So year underscore R. We provide the survey design argument, the DNSDUH, and then the function SBY mean. Remember, SBY mean is going to compute a mean for continuous variables or a proportion for categorical variables, or factors are called categorical variables factors. These other arguments here, so this one is telling R that if there is any missing values, just remove them. So na.rm equals true. And this is optional, you can have it or not. I'm just suppressing the standard errors from the output, so I'm saying keep variance equals false. And then all of this is wrapped around this function ftable, which is just a way of showing the results in a tabular manner. You don't need it, you can actually erase it, and you will get the same thing. Okay, so we're gonna run this line of command. Here we go. So turn your attention to the console. You see that the second row shows you the prevalence of past year heroin use in the first period, so 0.00158. The fourth row shows you the prevalence of past year heroin use in the second period, 0.00238. These numbers look a little bit different from the table, right? Like these are very small, and that is because the table presents the results multiplied by 1,000. So look back at the code, and what we do is we are repeating the same line of command. We're just multiplying it by 1,000. So let's run this, and now you get the exact numbers that you were shown in the table. Now, the table doesn't show confidence intervals for these prevalences, but you could get them if you use the function confint that is wrapped around the function that we use to estimate the prevalences. Again, we multiply this by 1,000 because these are presented as prevalences by 1,000. So we go ahead, run this, and now you have in the last two rows the confidence intervals for the prevalence of heroin use in the first period and the confidence intervals for the prevalence of heroin use in the second period. Okay, The table also shows that these two numbers are statistically different, so we're gonna do some test. We're gonna do a chi-square test. So remember, again, you have your the way to specify, or the arguments for this function are similar to what we have been doing. First, you call the variable heroin use using the formula sign. Then use the plus sign to say I want to test the heterogeneity by this grouping variable, which is the time period. You provide the survey design and then the statistic chi-square. Now, you might have noticed that this code is a little bit more simplistic, that I did not write design equals NSDUH. Why I didn't do that? Because as long as you provide the correct argument, R knows it. So I don't need to write this. I can suppress it. Actually, if I were to provide this argument at the end of my code for computing a chi-square, it wouldn't matter. Okay, it will still show and give me the same results. So we're gonna go ahead and run this. Great. So now you see here in the console that we have our estimate of the chi-square, degrees of freedom, and a very low p-value. So these are indeed statistically different.